Here we go, 4.2. How do we simplify radicals with indices larger than 2? So last class we were only talking about 2, and all we really cared about was dividing by 2. So that's kind of what we're doing today, except we're not going to have 2 there the whole time. So square roots. Alright, the square root of 9, you're asking yourself what number multiplied by itself 2 times, because technically, let's get that straight, technically there should be a 2 right here. So what number multiplied by itself 2 times is 9? You already know it's 3. Alright, what number multiplied by itself twice would make x squared? That's going to be x. That's a horrible x. Okay, the problem is when we get to x to the 5th, we just can't do that. So we have to break it up into a square root that we know and a square root that we don't know. So I know the square root of x to the 4th. That's the largest number underneath 5 that I can divide by 2, and then I'm left with the x to the 1st, which nobody really writes, but you can put it there. So that becomes x squared, square root of x. Well, not much is really going to change today. A third root is really saying what number multiplied by itself 3 times to make 27. So what number can I multiply by itself 3 times? Well, 2 times 2 times 2 is not going to work. That's going to be 8, right? And 3 times 3 times 3, well, that actually works. That's 27. So we get 3 because 3 to the 3rd is 27. Okay? So when I have the next problem, all right, the third root of x to the 3rd, well, I'm looking at it, and if over here I was just dividing by 2, then what do you think I'm dividing by here? Yeah, you guessed it, it's 3. So I'm just going to take this 3 and divide it by this 3 and end up with x. It is that simple. Just like on this problem over here, I took that 2, divided it by that 2. Well, just like here, I have 5 divided by 2, it doesn't work. I have 7 divided by 3, it doesn't work, so I have to rewrite this as the third root, oopsie, gotta have the pen, the third root of x to a number, that's going to be 6, because the largest number underneath 7 is divisible by 3 is 6, and then whatever is left over, so that's the third root of x to the 1st. Notice that we have a 6 and a 1, which makes 7. 6 is divisible by 3, so when I divide it, I end up with the third root and the 6 canceling to make 6 divided by 3 is 2x squared. And then we have times the third root of x to the 1st. Now you do want to be careful to make sure that your 2 and your 3 aren't too close together, otherwise it looks like x to the 23rd or the 23rd root of x. Those are both bad things that won't get you much credit on your test. Let's move on to 4th and 5th roots because they're not much different and it works out. So the 4th root of 81. Okay, well, 81, if you type in your calculator 3 to the 4th, you'll see that 3 to the 4th is 81. And just like when dividing by 3, if the index is 4, so we divide by 4, 4 divided by 4 cancels, and we are left with the answer, which is 3. Okay, next one. Same idea, we have to divide. So this exponent right here has to be divisible by the index that we have of 4. 4 divided by 4 works out nicely, so we are left with x to the power of 1. The last one, 9, is not divisible by 4. Not last I checked. So we need to break this up into something that is divisible by 4, and then whatever is left over is left over. So we are going to have a 4th root. So the 4th root, let's try that again. There we go, 4th root. And a 4th root, we have one that we know, one that we don't. I can divide 8 by 4, so I'm going to go x to the power 8, which leaves me with just a 1 left over here. That's nice. 8 divided by 4 is going to give me x squared times the 4th root of x to the 1st. And there we have it. All right, moving on to the 5th root. So 243. So you can try a bunch of numbers raised to the power of 5. It does work out to be 3. So the 5th root of 3 to the 5th is what we're looking for. And if you just do many number factor, it breaks it right down to, that would work as well. But anyways, 3 to the 5th. 5th root of that, the 5's cancel. We are dividing again this exponent by that index. So we get 5 divided by 5, cancels just to make the 3. Same with the next one. All right, we have 5 here, divide the 5s, we are left with x to the power 1, which you don't always have to write. The last one, it does not work. We got to break it up into what we know the fifth root of and what we don't. So I have a fifth root, something I'll be able to divide by 5, and then I have a fifth root of whatever is left over. So the largest number underneath 12, this exponent here that I can divide by 5 is going to be x to the 10, power of 10, so x to the 10th, and that means I'm left with an x squared. 10 and 2 makes the 12. Now that I can divide, I will. 10 divided by 5 is x squared times the fifth root of x squared. And there we have it. We're good to go. Let's move on to some actual questions. Okay, question number 1. Alright, so we're going to break this up. We're using third roots, so we're going to do menu number factor in the calculator. That is going to give us 3 to the third times 2. So I'll write that up here. This is 3 to the third times 2. Same way we did it before. Alright, so the third root of 3 to the third. And then I have a third root where I don't know things. That's just going to be the 2. X to the 6th. Well, I can divide that power of 6 by 3. So it's going to stay that way. X to the 6th. The y, I cannot divide the power of 1 by 3. I can't break it up, so we're left with putting the y on the far right side. Everything on the far left-hand side over here is totally divisible by 3, these exponents, so I divide them by 3. I get 3 to the first times x squared, all multiplied by the third root, write that nice and small, of 2y. And again, you do want that small so it doesn't look like it's 23, or just put a little space with a dot in between. That makes it pretty easy. Question 2. The third root of 56. So we have to do menu number factor. 56 breaks down with 2 to the third times 7. So 2 to the third times 7. So we have a third root we know, a third root we don't know. 2 to the third is going to be divisible by 3. The 7 goes over there. I have u to the 6th I can divide. Same with v to the 6th. But that's going to leave me with some leftover stuff. So u is supposed to be to the 7th, so I've got 1 u left over. V to the 6th, I have from v to the 8th, so I have 2 v's left over there. On the left-hand side, over here, everything I have, I can divide by 3, 3, 6, and 6. But on the right-hand side, I have nothing. That's the way it's supposed to go. So we divide, we get 2 u squared, v squared. Don't forget your multiplication symbol. Third root, write it really small, close to the square root, the radical. 7uv squared. And there you have it. All done. Let's move on to question 3. This is a fourth root, so be careful. So now maybe you start off by writing fourth root right away so you know you're not dealing with third root or square root. So we do menu number factor. 3 of 32, I apologize, is really just 2 to the 5th. That's all it's going to be broken down to. So I have to break it up into what I know the fourth root of and what I don't know. So I have 2 to the 4th. I can definitely divide 4 by 4, but I can't divide the 5 that it was. So I'm left with a 2 to the 1st over here. A squared is never going to be broken up into something that can be divisible by 4. So we just write the whole a squared to the right. B to the 6th, on the other hand, I totally can break that up and should. So I have a b to the 4th. That leaves me with a b squared over here. And again, remember everything on that right square root, or radical I should say, is not going to be broken up. Not going to change. So left-hand side, 4 divided by 4 for both of them gives me 2b times, try and write a small 4. It's tough to do with this stylus. And we have really ugly 2's, but 2b times the fourth root of 2a squared b squared. Alright, let's move on, try some more. Alright, question 4. Go to your 128. Menu number factor of 128 gives you 2 to the 7th. Tons of fun. So that is 2 to the 7th. So we need to break that up. So we have a fourth root that we are going to know, and a fourth root of whatever's left over. So 2 to the 7th gets broken up to 2 to the 4th, 2 to the 3rd. M squared, that 2 is never going to be divisible by 4, so I can put my m squared over here. The end of the sixth, I can totally break it up with a 4 and a 2. So to find the fourth root, we're going to divide by 4. So 4 and 4 divided by the 4 just gives us 2n. They cancel to make 1. So fourth root of, copy everything inside. Now 2 to the third I shouldn't have copied because we all know what 2 to the third is. It's 8. And then m squared, n squared, we just copy. And that should be it. Okay, let's try another one. Oh yeah, fifth root with a negative. Okay. So fifth root and fifth root. All right, so 256 when you do menu number factor is 2 to the 8th. Wow, that's tons of fun. Not really. So 2 to the 8th. Okay, that is an ugly 8, sorry. We have 2 to the 5th, 2 to the 3rd. A squared cannot be divisible by 5. B to the 6th I can break up to b to the 5th and b to the 1st. And then there's the problem of the negative. So when you multiply, the negative actually goes in here. Why does the negative go in there? Well, the fifth root means, can I have 5 negatives multiplied together and still produce a negative? And the answer to that is yes. You could have 5 negative ones multiplied together. If you need to write it out, you totally can. Negative 1. Okay, so when I multiply them together, I have these two negatives make a positive, these two negatives make a positive, positive 1 times the negative 1 left over, still give me a negative. So I actually have, and I didn't write it here, but I actually have the negative 1 to the 5th is, the 5th root of that is still going to be negative 1. So we end up with a negative 2b, and then 5th root of 2 to the 3rd is 8, a squared b. So the rule here generally, the rule of thumb is anytime you have an odd number for the index up here, 5, 3, 5, 7, 9, so on and so forth, you're going to have a negative in your answer. You won't see a negative with anything other than square root. A negative with a square root, obviously, is the imaginary unit I, and you won't see any other even powers. So if you're worried about that, you won't see 4, 6, 8, 12. That is far beyond the scope of this course. But anytime you have a negative underneath an odd index, you can just put a negative in your answer, what that amounts to. All right, sixth, last one, where you get some practice on your own. Fifth root of 160. So you go to the calculator. It is 2 to the 5th times 5. We're going to break it up. It's the 5th root. 5th root. So 2 to the 5th goes over here. 5, obviously I can't. X to the 3rd, I cannot divide 3 by 5, so I just stick it all over there. Y to the 5th, I can. There's no breaking it up. So we divide, we get 2y, and then the 5th root of 5x cubed. And we're good to go. So go ahead. We're going to take a second. I'll do the menu number factor for you for 256. That is going to be 2 to the 8th. So this is 2 to the 8th. For 64, it's going to be 2 to the 6th. No, come on, 6th. And then for the last 324, it's 3 to the 4th times 2 squared. 3 to the 4th times 2 squared. So go ahead, pause the video right now, and try question 7, 8, and 9 to make sure that you can do this, because we're going to step it up a notch on the next page. Pause the video right now. Okay, so here's the answers. Go ahead, pause it and check them, and I'm going to move on to the next page now. Alright, so here we go. Negative under a root. So the 3rd root of negative 8. Well, the 8 breaks down to the 2 to the third, so we are going to know the third root of that. And then you have to ask yourself, can the negative, and essentially it's a -1 just like we had before, can that -1 be multiplied by itself 3 times and still produce a negative? And hopefully the answer is yes. So -1 times -1 multiplied by -1 would make a negative. So the number that multiplied by itself 3 times that made -1 is -1. That won't ever work if the index is even, only works if it's odd. So in this case we have the third root of -1, which is still a negative, and the third root of 2 to the third, which is going to be 2. So our answer is just plain and simple -2. Okay, the third root of -27. Okay, so third root, again, the -1, yep, -1 multiplied by itself 3 times. So we're going to have a negative in our answer. We're also going to have the third root of 27, which, conveniently enough, you can see 3 to the third. It's just going to become 3. So our answer is -3. You can also type this in the calculator with the nth root if you hit Control and then the caret button, which is next to the 4, next to the x squared. If you type that in, you'll see those. The last one is more of the same. Same thing, third root of the -1 times whatever 125 is. When you do menu number factor, that is 5 to the third. So we end up with a negative again, and 5. Okay, if it was the fifth root of something that had a negative underneath, it would still be -1, because 5 negatives multiplied together would still make a negative. Just remember that the square root of -1, all right, that is a horrible 2. Try that again. The square root of -1, whether there's a 2 there or not, is the imaginary unit I. So if there's a 2 up here, or if it's square root without the 2 there, it's still going to be the imaginary unit. That's the most important part there. So, other cases. All right, well, we have to break this third root up into a 2x to the fourth that we know and a 2x to the fourth that we don't know. And this question looks really nasty, same with the next two, but they aren't really so bad. So, one of the things we have to notice is our patterns, and hopefully this pattern shows up for you. So, I need to break up 2x, think of it as just 2x raised to a power. Well, I know I can take that power and divide it by 3, so that's supposed to be 2x, and if it's a power of 3, I'm good to go, because I can divide the exponent of this 3 by this 3, and then whatever is over here is what's left over. Well, that is simply going to be, I already used 1 power, or 3, so I'm left with just 2x to the first. On the left-hand side, we know that the exponents cancel, so I'm left with 2x times, on the right-hand side, the third root of 2x. Next problem. Again, you're looking for that pattern, so I have something to the power 8. Alright, since it's to the power 8, I need to be able to divide it by 5. Just draw a little line here so we can see. So it's the fifth root of something, and the fifth root of something that's left over. So again, we have 14 minus 5x is what's inside parentheses. Okay, so the exponent that's below 8 that I can divide by 5 is going to be 5, which leaves me with an exponent over here of 3. And then I just go ahead and simplify. So 5 and 5, when I divide this 5 right here by this 5 over here, I end up with 14 minus 5x. Just cancels and leaves it out. There's no more parentheses, well, no more exponent, I should say, times, and then I write the fifth root of 14 minus 5x to the third. Same thing happens with the next problem. So it's a fifth root that I know. Oops, just make that a little bit bigger. Fifth root that I know. Fifth root that I don't know. And again, it's going to be AB minus CD to a power. So AB minus CD. The power on the left side has to be one that's divisible by 5. So the largest number under 7 that's divisible by 5 is 5. What's left over here is a 2. The 5s are going to cancel, and we're left with AB minus CD. Do need parentheses. We'll talk about that in a second. 5th root of AB minus CD squared. Now, why do we need parentheses is a question. All right, if it's CD and it has a dot and then the 5th root, it's going to look like it's just CD multiplied by all this, when in fact it is supposed to be the entire quantity of AB minus CD. Aside from that, pretty good shape. Here's some practice problems for you to try. And don't forget, the answers are right over here. If you flip it over, ooh, there they are. Anyways, there's your answers. When you're done, don't forget about your summary. We will be looking to make sure that you have done the practice problems in here and then written a summary. Thank you.